Hi everyone, welcome to the past paper 4 B2 C2 P2 higher run through. Remember, you always have these equations in the front of your booklet. Use them specifically in the physics section. But the first section is biology. So the first question, look at the woodland food web. Here's the food web. So the food web shows that the dead leaves are eaten by the snail, woodlouse, earwig and millipede. The ground beetle eats the earwig and millipede, but the beetle larva eats the snail and the woodlouse, and the wolf spider eats the beetle larva and the ground beetle. It says, look at one food chain in this web showing the numbers at each level. There it is. What would you expect the pyramid of numbers and pyramid of biomass to be the same shape for this food chain? Or would you expect it to be the same shape? And explain your answer. So you don't get a mark for what your answer is in that it's no. You've got to explain it. So you need to put something like, because larger number of beetle larvae would feed on a smaller number of snails, or snails would have more biomass than beetle larvae, something like that. Or you could draw a correct pyramid of number. So the idea that you'd have dead leaves, loads of them like that, then you'd have snail, not many, feeding on the dead leaves, and then beetle larvae like that. So that would be your pyramid of number. So you need to say no, but then the explanation is what you get the mark for. The woodlouse and earwig are in the same trophic level. Some energy from this trophic level does not pass into the next trophic level. Write down reasons why. So 2 marks. Any two from these could say heat from respiration, excretion, or egestion. You could say urine or sweat. So you could, instead of saying excretion, you could give one of the products. You could say feces, even though that's not technically excretion. They allow that. Or you could say uneaten parts. They would allow that too. The efficiency of energy transfer between trophic levels can be calculated. Look at the data on energy flow through 4 trophic levels: producers, primary producers, consumers, secondary consumers, and tertiary consumers. The efficiency of energy transfer between producers and primary consumers is 7.2%. The efficiency of energy transfer between primary and secondary consumers is 8.6%. It says calculate efficiency of energy transfer between the secondary and tertiary consumers. Now, the fact they've given you these numbers means that if you're not entirely sure how to work this out, you could, if you have time, and I wouldn't spend loads of time on this thing, it's only worth 1 mark, but you could just manipulate these numbers to see what would give you these numbers. And basically, if you divide 600 by 7,000 and times that by 100, that'll give you 8.6%. And if you divide 7,000 by 97,000 and times by 100, that'll give you 7.2%. So it makes sense that this one is going to be 50 divided by 600 times 100, and that gives you 8.3%. So next, use your answer to part 1 to explain why it's unlikely that there will be a 5th trophic level. So 2 marks here. First mark saying that you're only transferring around 8%, so there's not enough energy to support a 5th level. And then a second mark is for working out what 8% of 50 kilojoules is, and that's about 4 kilojoules. So yeah, those are where your 2 marks are for. This question is about pollution. The name of one type of mayfly larva that lives in streams is Ephemera danica. Probably not pronounced like that. What does this name indicate about the classification of this animal? Write 1 in the box next to the classification indicated by the name Ephemera, and write 2 in the name box next to the classification indicated by the name Danica. So this question is often asked in lots of different guises, but essentially it requires you to understand the what these names represent. And the first part of the name represents the genus. So that's where you're going to put the 1. The second part of the name represents the species. So sometimes this may, they may give you this name and say, what is the species of this animal? And you have to put Danica. So you're just using the name, but you just need to know what those 2 parts of the name actually mean in order to answer those questions. The binomial system is used to name Ephemera danica. Why is the binomial system important when scientists name organisms? And this is the idea that it's the international basis of naming species, or it shows or is based on relationships, or it removes confusion, or you could say it's a universal name in all languages. So that means scientists all over the world will know what that name means. Look at the picture of stonefly larvae. This is an indicator species used to show levels of water pollution. Stonefly larvae live underneath stones in fast-flowing streams. Stonefly larvae have adapted legs that end in small hooks, and the body is flattened. Explain why stonefly larvae are described as specialists. So there's 2 marks here. First mark for saying that it has hooks that allow anchorage or a flattened body for crawling under stones. That means they're well suited. So you have to say they're well suited, and then for limited habitats, such as fast water hiding under stones. So the terms well suited and for limited habitats are what you need really to get those 2 marks. You could say that it's adapted to survive in a specific habitat or environment as well for 2 marks. That's probably an easier way of putting it, to be honest. So adapted to survive in specific habitats if it's a specialist. Okay, so this next question is the 6-mark question. So please mark this yourself using the Google site, the mark scheme that's on the Google site, and ask your teacher to check your answer if you're unsure whether you've marked it correctly. The picture shows a right whale. Biologists have measured the population of right whales in an area of the North Atlantic during 5 separate months. They also measured the amount of food available in that area and the energy in that food, and is also plotted on a graph. The ratio of whales to food energy in September and October is 1:1. What is the ratio of whales to food energy in July? So September and October, you could see. Okay, so reading this, it's essentially a question in reading the graph properly. So the ratio of whales to food energy. So that's whales and food energy there. So ignore the whale food for now. You can see that in September and October that those 2 things were the same level. So that's why it's 1:1. But in July, you need to read off the graph. So whales, you can see that it's up to 0.05, and food energy is 0.2. So your ratio here is actually 0.05 to 0.2. And you can leave it like that if you wish. Actually, you can't, sorry. That'll only get you 1 mark. What you need to do is get it up so there's 1 to something. So that is 1 to 4. If you divide both sides by the smallest number, that'll give you the ratio in a whole number. So that'll get you just 1 mark, but getting up to this will get you the 2nd mark. Right whales are critically endangered. Biologists think that their results show that whale food energy is linked to whale population size in a particular area. They think it will allow them to predict where migrating whales can be found. Use your answer to part 1 and information in the graph to evaluate their claims. 3 marks here. So you can get 3 marks for any 3 of these. You could say that more whales if there's more food energy. So overall, there's more whales if there's more food energy. You could say whales migrate to where there is more food energy. You could say, but in October, there is less food energy than August, but more whales, and therefore the ratios aren't constant. It's 1:1 in September and October, 1:2 in August. You could also say things like that food limits population size, or the whales are following the food. So any 3 of those points will get you those 3 marks. Whales are thought to have evolved from animals similar to the hippopotamus by natural selection. Put the following statements in the order of 1 to 4 to best explain the theory of evolution by natural selection. The first one's been done for you, and write numbers 2 to 4 in the other boxes. So, first one, presence of natural variation. Then, there's a competition for limited resources. Then, following that, you get the survival of the fittest, and then the adaptations of those fittest survivors are then passed on down the chain. The right whale is adapted to living in very cold environments. What anatomical and behavioural adaptations does a right whale have to help it survive in its very cold environment? So, you've got 2 marks here. So you could say layer of blubber or fat. You could say it's got a small surface area to volume ratio. And you could say it's got a migratory habit to move to warmer areas. So any 2 of those 3 will get you those marks. So on to the chemistry section. So first question is about fertilisers. Ammonium sulfate is used as a fertiliser. The ammonium for ammonium full sulfate is NH42SO4. Write the number of elements in ammonium sulfate. So number of elements is the easiest one to work out, because essentially you're just counting the number of capital letters in the formula. So you've got N, H, S and O, all capital letters there. The reason why I say capital letters is because any symbol representing an element must be first letter capital, but then if there's any other letters in the element, for example sodium, the second letter will be a little letter. So if you just count up the capital letters, or different capital letters, then that will get that mark. So it's got 1, 2, 3, 4. So it's 4 different elements in there. Number of atoms, though, is slightly more tricky. So this time you've got to look at how many of each element there are. So, and also take into account the brackets. The brackets mean that any number outside that bracket represents there's that many of everything within the bracket. So you've got 2 n's. So if we just write them on the side and count them up, so 2 n's, because there's 1 n inside the bracket and there's 2 lots of the bracket. You've got 4 h's, because remember the number just after the letter is what represents how many there are. So 4 h's inside the bracket, but there's 2 lots of them, so that's 8 h's. 1 s and 4 oxygens, so that's 2, 10, 11, 15. So there's 15 atoms in the formula. Next question is a 6-mark question, so please mark this yourself using the mark scheme on the Google site and ask your teacher to check whether it's correct or not. Next, Sam investigates the action of heat on copper carbonate. Look at the diagram, it shows the apparatus he uses. Look at the word equation of the reaction. This is a thermal decomposition reaction. Explain why. So thermal decomposition is where, well, the copper carbonate, you can just put the copper carbonate as broken down, but fully, I'd rather you said it's broken down by using heat. That's what thermal decomposition means, but I think they've let you off that in this question by saying using heat because it's obvious that heat is being used. But the full definition of thermal decomposition is that something is broken down using heat, so you may as well use that full definition if they ask you why something is thermal decomposition. Sam makes copper. He heats some copper oxide with carbon. Copper and carbon dioxide are made. Write a balanced symbol equation. So you've got he heats copper oxide, CuO, with some carbon, and you're making copper plus carbon dioxide. So it's slightly more difficult than you've balanced in the past. The burning or complete and incomplete reactions are slightly more easy to balance. So here you've got 2 oxygens on this side, but you've only got 1 here. So you need 2 lots of this whole compound here, but then that affects your numbers of copper. So you've got 2 coppers now, so you need to have a big 2 in front of that copper as well. So writing it out first is 1 mark, and the second mark is for balancing. The copper Sam makes is impure. Look at the diagram, it shows the apparatus used to purify copper. Look at the equations below for electrode reactions, there they are. Which reaction is oxidation, which reduction, explain why. So you can't just put which one is oxidation, which one is reduction, you have to say why you think that as well. So, remember, what you need to remember here is oil rig. So that means that oxidation is loss of electrons and reduction is gain of electrons. So if the electrons are being taken away, that means they're being lost. So the anode is oxidation. So you need to put anode is oxidation because electrons are being lost. So that's 1 mark. And then the cathode is reduction because electrons are being gained. So you need to say why, and putting why is just the idea that electrons are lost or gained, but you must put that to get those 2 marks. Use the electrode reactions to explain why the anode loses mass and the cathode gains mass. So, first mark, the anode loses mass because the copper ions go into the solution. So, you've got your solution of copper sulfate here. The anode, the copper in it, will first dissolve into this solution. That's why that will lose mass. And then the cathode gains mass because the copper ions gain electrons and become copper. So what happens is the copper dissolves into the copper solution, moves across the cathode, and it will gain electrons at the cathode and create copper there, and therefore that will gain mass. Explain one advantage and one problem of recycling copper. So, advantage that it saves resources, or it uses less energy, or there's less environmental damage, either there's less quarrying. And then one problem, so copper has to be collected and it also has to be sorted, so either one of those 2. Next question, look at the table, it shows some properties of 3 metals. Look at the picture, it shows overhead power cables used by electric trains. Which metal would you choose to make the overhead power cables, and justify your answer? Now, the first thing is you must ensure, although these all look fairly relevant, but ensure that if you get a question like this, you've got to make sure that you choose the relevant properties. So here, there's 2 marks. So you don't get a mark for your answer, you get a mark for justifying it. So if you could choose either aluminium or copper, but you've got to say why. So if you chose aluminium, you've got to say it's because it's got the lowest density and it doesn't corrode. Or you could use copper because it's the best conduction and only corrodes slowly. So you don't really want to be talking about the relative strength or the cost in this case. Ethanol can be made from ethene and water. The flowchart shows this process. The symbol equation of this reaction is that. The percentage of ethanol change, the temperature and pressure change. Look at the table, shows the percentage of ethanol at different temperatures and pressures. Which of the following conditions give the highest percentage of ethanol? So, first thing to do is identify the highest percentage. So, you've got up to 20 there, and then 60. So 60 is the highest one. So you've got the lowest temperature, and you've got the highest pressure. So that means it's B, high pressure, low temperature. The conditions for making ethanol are 300 Celsius and 60 atmospheres pressure. Suggest why these conditions are used even though the percentage of ethanol is only 20%. So there's 2 marks here, but there's quite a few answers you could give. So you could say the temperature or pressure chosen is a compromise. So that's 1 mark. You'd say the high temperature gives a high rate of reaction. You could say the high pressure increases the percentage yield of the ethanol. You could say at higher temperatures the percentage yield is lower. And you could say at higher pressures are expensive to maintain or generate. Or you could say it's unsafe, so it's risky. So any 2 of those 5 or 6 points will get you those marks. This question is about the structure of the Earth. Look at the table of densities. There it is. The lithosphere, or lithosphere, includes the crust and outer part of the mantle. The lithosphere is made of tectonic plates. Some scientists claim that these tectonic plates float on the inner mantle. How does the data in the table help support this claim? Remember, things that float will have a lower density of things they're floating upon. So you've got to just say that the lithosphere has a lower density than the inner mantle. So if you look at the table, the crust in the outer mantle has a lower density than the inner mantle and therefore will float upon it. In 1914, Wegener proposed a theory to explain the structure of the Earth. This was not accepted by many scientists at the time. His original theory has now been developed into the theory of plate tectonics. This developed theory is more widely accepted. Explain why developed theories are more widely accepted. So a developed theory is one where there is a greater range of evidence and the idea that more scientists have discussed or tested the theory, or there's better technology. So any 2 of those 3. So we're on to the physics section now. So first question about nuclear radiation, and complete the diagram to show the penetrating power of alpha and beta radiation. Gamma radiation is being completed for you. So remember that alpha can be stopped by a few sheets of paper, so that will just go to this one, and the beta is stopped by aluminium. So there's 2 arrows for that 1 mark. Write down 2 examples of beneficial uses of gamma radiation. So any 2 of these, you could say the treating or curing cancer, or radiotherapy. You could say non-destructive testing. You could say tracers, or you could say sterilizing equipment or killing bacteria on surgical equipment. So any 2 of those. Explain the problems of dealing with radioactive waste. So again, a number of different things you could put, but any 2 of these. So you could say it must be placed in a material resistant or thick enough to stop the radiation from getting out. So you could say it has to be encased in glass or placed deep underground. You could say that it has to be contained for a long time. You could say it may remain radioactive for a long time, so long-term solutions are required. You could say it must be stored where there is no possibility of it contaminating water supply. That's important. Or you could say that they need to monitor levels of radioactivity for long periods of time. You could say that there's a risk of terrorism using the plutonium, or terrorists could use it to make a bomb or a dirty bomb. So any 2 of those points will get those 2 marks. This next question is a 6-mark question, so please mark this yourself. Then use the mark scheme on the Google site to mark it yourself, please. The sun's energy produces convection currents that cause wind. Wind is used to drive turbines. There it is. Describe the advantages of wind turbines compared to a conventional coal power station. So again, a number of different things you could say. So any 2 of these. You could say that it's renewable energy. You could say that there's no polluting waste produced. You could say that crops can be grown into them, or they could be placed at sea. You could say they're useful in remote locations. They need less maintenance or less staff, you could say. You could say there's no carbon dioxide produced, but that's similar to no polluting waste. So any 2 of those will get you those 2 marks. The people in the house are concerned about noise from the turbine. Look at the graph. Use the graph to describe how the wind turbine noise is affected by wind speed. So this is just reading the graph and doing a trend. So as wind speed increases, the noise increases. That's all you need to put there. The mean wind speed in this area is 5 meters per second. The maximum wind speed in this area is usually less than 15. Explain using data from the graph why the people in the house do not normally need to worry about the noise from the turbine. So first part is saying for low speeds, or up to 5 meters per second, the noise level is below the background radiation. That's 33 decibels. So at 5, it's below this background radiation, which is this line here. And then at high speeds, above the mean speed, the noise level is generally below or not much above the background. So up here at high speeds, the noise is below that background noise. So those are your 2 marks for that question. Kyle has a wireless computing system. Look at the information in the diagram. The monitor plugs into a 230 volt supply and uses a current of 0.5 amps. Calculate the power of the monitor in kilowatts. So look up the equation in the front of the book. So power is current times voltage. So you're going to do 230 times 0.5, and that gives you 115. Now that's in watts, remember, but they want the unit in kilowatts. So that'll get you 1 mark. If you put 115, that's 1 mark. But to turn it into kilowatts, you've got to divide that by 1,000, which gives you 0.115. So kilo means 1,000. So in a kilowatt, there is 1,000 watts. Just like in a kilometre, there's 1,000 metres. So to convert watts into kilowatts, you've got to divide it by that 1,000. The energy supplied to the desktop PC in a day is 0.45 kilowatt hours. How many hours does Carl use the PC for that day? So to answer this question, you need this value here. The fact the power he's using is 90 watt, or the power that the desktop PC needs is 90 watts. Now this is in kilowatt hours. The first thing to do is divide the 90 by 1,000 to turn it into kilowatts. That's 0.09. And then to work out how many kilowatt hours are used, you do 0.45 divided by 0.09, which equals 5 hours. Now if you put 0.45 divided by 90 to get 0.005, that'll get you 1 mark because you didn't convert the watts into kilowatts. The monitor and the desktop PC are connected to a 230 volt supply. The mouse and the keyboard are 3 volt batteries. Put the 4-part system in order of the size of current used, and the first one will be done for you. So the top should be the monitor, and then you get the desktop PC, and the lowest current is the mouse. Increasing use of technology has increased energy consumption. This may have contributed to global warming. People have different views about reducing energy use. Fatima thinks that it would help if everyone changed to using low energy light bulbs, and Claire thinks we could all reduce energy used by walking instead of driving cars. Analyse his views and discuss how effective they could be for reducing global warming. So 2 marks here. And to get 2 marks, you've got to have a correct idea from Fatima and a correct idea from Claire. So the idea that Fatima and Claire's idea reduces global warming, or uses less energy, or uses less fossil fuels, or reduces greenhouse gases, and then anyone from the idea that depends on the number of people taking up these initiatives, or that Claire's idea is impractical, so it would only apply to short or local journeys, or it's unrealistic that people would give up using cars, or some vehicles are essential for health reasons, jobs, or living in country. So first mark saying that both of those ideas would reduce global warming, but it would depend on the number of people taking up the initiatives, or that Claire's idea is impractical. So, final question. Electricity is generated in power stations. The efficiency of this power station is 34%. Calculate the total energy input from the coal. So, you've got to work out what 770,000 megajoules is 34% of. The easiest way to do that is do 170,000 divided by 34% as a decimal. So that's 0.34. And that'll give you 500,000. Then the next question, the generator in the power station produces alternating current AC. Look at the 3 different current time graphs. Described by all the graphs show alternating currents. That's the idea that for each graph the readings change to above and below 0. So that one goes above and below 0, that one goes above and below 0, and this one goes above and below 0. So that's what you need there, just the idea that there's readings that are positive and negative, or that flow in 2 directions. Any of these ideas will get you that 1 mark. So add up your scores, write it on your poster, and now try the next paper, please.